In this lesson we're going to focus on the phase shift of a function, and the phase shift I think is new to kids that have been in Algebra True Trig, and a phase shift is basically a horizontal shift of our two sinusoidal functions, either the sine curve or the cosine curve. So we're going to write it first, and then I'm going to show you how to sketch graphs using a phase shift. So here we have our two sinusoidal functions. The sine curve, we have the amplitude A, and we have the B value, which is the period that you use that to give the period length, and then the minus h, this is our phase shift, and it's counterintuitive, just like any other horizontal shift. This is going to shift the sine curve h units to the right. Now if you notice, the B, the coefficient in front of the variable, must be factored out to appropriately read the phase shift. So this is just like we did, what we did with transformations. When we had a dilation inside the function and a translation, the dilation had to be factored out. So my B coefficient is factored out, then I can directly read, or I can read the phase shift. It's counterintuitive, so if it's subtraction, it's going to move to the right. So in your book, in the FLCC book, that book talks about a horizontal shift and a phase shift. And what we're going to do is we're going to treat them both the same, and it's going to be what you get when you factor the B coefficient out in front. So we're going to work a couple of basic examples, and all we're going to do is identify the amplitude, period, and phase shift for a given function. So here we have our function, g of t is equal to 5 cosine, and then all of this is inside the cosine function, 2 times the quantity t minus pi over 2. Our amplitude is the positive, the absolute value of the coefficient, so the amplitude is going to be 5. In order to get the period length, I need the coefficient of the independent variable, so I know the period is going to be 2 pi divided by that b value, so I have a period length of pi. And then the phase shift, since my b value is already factored out, this is going to be a direct read. It's pi over 2. Since this is subtraction, it's going to be positive pi over 2, or pi over 2 to the right. So we can say it's positive pi over 2. So next we have an example that requires a tiny bit more work. We have h of t as our function. It's equal to negative 2 times the sine of 2t plus 3 pi. So please, let's look, at first, the first thing we want to do is identify the amplitude. It's the absolute value of negative 2. So please don't tell me it's negative 2. It's the absolute value of negative 2 because the amplitude is always positive. It's like a dilation. We only dilate with positive scale factors. So amplitude is 2. I need to get the b value out of this thing. The b value is the coefficient in front of t, so that's 2, which means the period length is going to be 2 pi divided by that coefficient. So my period length is once again pi, but I can't read the phase shift yet because my coefficient is not factored out. So I'm going to take this function and I'm going to factor out the b value, still keeping it inside the sine function. When I factor out a whole number, I need to pull a 2 out of a 3 pi. All you're going to do is take this coefficient and divide it into that. So 3 pi becomes 3 pi over 2. Now I can read the phase shift. It's positive, which means it's going to be going to the left, so I'm going to make my answer negative, and the phase shift is 3 pi over 2. So the phase is going to be negative 3 pi over 2. So that's the first part, just identifying amplitude, period, and phase shift. The next part is sketching functions with a phase shift. So now I'm going to show you how to sketch one period length of a function over an appropriate interval. And we do this, when I say sketch, that means we're not going to be focusing on graph paper with grids. What we're going to do is sketch the standard curve and then scale around it. Remember the sine curve, if I think about what we would consider a parent function or one period length of a sine curve, it starts at the center, increases, and then ends at the center. That's the standard sine curve. The cosine curve starts at max and then goes to a min and ends at max. So we're going to graph these two curves because the curve itself doesn't change. You're just going to change the scaling around it, which makes it a little bit easier. A couple things just to write down before we get started. What you want to do is, first of all, list the amplitude, period, and phase shift, because you're going to use those to create your scale. So you do find those three things. And then, for the interval, you're going to start at the phase shift, whatever that phase shift value is. Because if you think about it, the phase shift is shifting your function left and right. So if I start at the phase shift, I'm going to create my standard curve, because the phase shift just takes this curve and either moves it to the left or to the right. So that enables me to use my standard curves for sine and cosine. And then what I'm going to do, to end it, I'm going to add one period length, whatever that is, to the phase shift. And that's my end point. I think the trickiest part about this is dealing with radians, because again, you need to deal with fractions, you need to add fractions, you need to find like a center point between two fractions. That's always the trickiest part. So we're going to do a couple of examples here, and then we'll work more on this in class. So here's an example. I'm going to sketch this function, y equals 2 times the sine of x plus pi over 2, over an appropriate interval. So I need to create the interval. I'm going to use my interval notation. I need a starting point and an ending point. That's going to be my x interval for my horizontal axis. So if I look at this, I'm going to pull out the amplitude and the period and the phase shift. The amplitude is 2. The period, since the coefficient in front of the x value is 1, the period's going to be 2 pi, and the phase shift is going to be negative pi over 2. Those are all directly pulling from what's in the function here. So my steps were to start at the phase shift. So this value, negative pi over 2, is going to be my starting point for my interval. I'm going to start at negative pi over 2. And then I have to add these two values together. So to negative pi over 2, I have to add 2 pi. Well, we've done this before. When I need to add the equivalent of 2 pi to a fraction, it's negative pi over 2 plus 4 pi over 2. That's going to give you 3 pi over 2. So that's where I'm going to end. So there's my end point. I need to see this interval when you do these problems. I need to see this on your paper, or you're not going to get credit. Okay? It's the sine curve, so I know it's going to start in the center and increase and decrease and end in the center. I'm going to start at negative pi over 2, so I'm going to be starting to the left of the y-axis. And I can do this just by sketching my standard sine curve, and I'm going to scale around it. Now yours is probably going to look better than mine. There is no midline shift. If I think about this, this is going to be negative pi over 2. This is going to be 3 pi over 2, which means this point right here is the halfway point between negative pi over 2 and 3 pi over 2. And if you think about it, the halfway point between those ends up being pi over 2. Which means halfway between pi over 2 and 3 pi over 2 is pi, and that makes the maximum point at 0. Okay, so this is my t-axis, this is my y-axis. Now I just need to scale the y side. Well, my amplitude is 2, so that means this is going to be 2, this is going to be negative 2. That's how you graph an appropriate or a sine curve over an appropriate interval. All we did was scale around it. We graphed the standard function, the standard curve, and we just had to mess with the scaling to make it right. All right, we're going to try one more. We'll make it slightly more complicated for you, and then we'll practice this in class. I want to sketch y equals 4 times the cosine of 3t minus pi. Well, my coefficient is not factored out, so let's do that first before I forget. Y is equal to 4 times the cosine of 3, and this ends up being t minus pi over 3. So this is going to be a little bit more fraction-y to figure out. My amplitude is 4. My period is going to be 2 pi divided by 3, because that's the coefficient, and the phase is going to be a positive pi over 3. The cosine curve starts at maximum. So my interval is going to start at pi over 3, and I got to figure out where it's going to end. To figure out where it's going to end, I'm going to start at pi over 3, and to that I'm going to add 2 pi over 3. So the denominators are the same, 2 pi over 3 plus 2 pi over 3. That's going to be 3 pi over 3, so that's going to end up being pi. Now let's think about the halfway point too. Let's sketch the graph. I'm going to start by sketching the standard cosine curve. There is no midline shift, so I'm going to put in the midline. And now I know I'm starting at pi over 3, and I'm ending at pi. I want to find the middle point, I want to find this point and that point. Let's scale the y-axis while we're here. The amplitude is 4, so I'm going to be at positive 4 and negative 4. So I'm going to find the halfway point between pi over 3 and pi. And to do that, you're going to add pi over 3 and pi, which is 3 pi over 3, and then divide by 2. So you get 4 pi over 3 divided by 2 brings you back to 2 pi over 3. If you're not sure about that, convert them to degrees and add them up and divide by 2. And you'll see that you get 120 degrees, which is the same as 2 pi over 3. Now I also want to find the halfway point between 2 pi over 3 and pi over 3 and 2 pi over 3. So you would add them up again. If I add these two and divide by 2, pi over 3 plus 2 pi over 3 is 3 pi over 3, which is pi, and divide by 2. This ends up being pi over 2. And 2 pi over 3 plus 3 pi over 3 ends up being 5 pi over 3 divided by 2, and this is 5 pi over 6. In terms of degrees, if this helps you, because this is a trickier problem, we've got 60 degrees, 90 degrees, 120, 150, and 180. So they're all spread out evenly. But once you finish with that, you're done graphing your function. You need to state the appropriate interval. So you start at pi over 3 and you end at pi. So this is usually the trickiest thing about graphing trig functions. So we will certainly practice more of this in class.